And welcome back. As we kind of wrap our discussion up around inner classes, let's go ahead and finish this up by talking about nesting inner classes, inheritance, and anonymous classes. So starting off with nesting inner classes, it is legal to nest inner classes within other inner classes. So you could have an inner class inside of an inner class and technically inside of more inner classes, but you eventually do need your outermost class. Now the rules are the same as what we've already discussed, except obviously the names can get very long, especially when we're trying to create all those new different types. So, for example, if A has a public inner class B and B has a public inner class C, then the following is valid. A object equals new A. A dot B object equals A object dot new B. A dot B dot C object equals B object dot new C. Again, you can see how those names are getting longer because they are all having to be inner classes of those nested levels. Now, of course, we can also have inner classes and inheritance tied together as well. Suppose outer class has an inner class named inner class. If you derived class from outer class, then technically derived class automatically has inner class as an inner class, just as if it had been defined inside of derived class. And just as with any other class in Java, you can make an inner class a derived class of some other class as well. You can also make the outer class a derived class of a different or the same base class. So inheritance is a very powerful tool still here that we can still use to help add a lot more oomph behind our program design. Now, one thing to note, it is not possible to override the definition of an inner class when you define a derived class of the outer class. Right? You can't change it. It's pretty much fixed in that original base class. It is possible to use an inner class as a base class to derive additional classes, but we're not going to go into those details because there's a lot of subtleties and nuance involved in doing so. The thing we do want to talk a little bit more about, though, is anonymous classes. If you wish to create an object but have no need to name the object's class, then you can embed the class definition inside the expression with a new operator. These sorts of class definitions are referred to as anonymous classes because they don't have the associated class name. An expression with an anonymous class definition is, like everything else inside Java, going to be inside of some class definition. And because it's inside a class definition, the anonymous class is actually going to be considered to be an inner class. Now, before we go into details about the full syntax for anonymous classes, let's just talk a little bit about how we might use them or where they might show up. The most straightforward way to create an object is using the following. Your class, an object equals new your class. This is something we've seen all the way back from when we first started introducing classes. Now, if new your class is replaced by some expression that defines the class, but does not give the class any name, then there is no name your class to use to declare the variable an object. So it doesn't make sense in this case to use an anonymous class in this situation. However, it can make sense in this scenario. Some other type, an object, equals new your class. You'll notice that they are two different types here. Here, some other object must be a type such that an object of the class your class is also an object of some other type. In this case, you could technically replace new your class with an expression including an anonymous object instead of your class. The type some other type, in this case, will typically be a Java interface. So let's look at this with an example to really kind of help clarify things. So here's an example of an anonymous class. Let's say we first start by defining interface, in this case number carrier, and all it has is these two methods, public void set number and public int get number. Then we created an object using an anonymous class definition. Number carrier an object gives a new number carrier, private int number, public void set number, and then public int get number. Of course, those are just implementations of the two methods from the interface. The part in the braces, of course, is the same part as inside the main braces of a class definition. The closing brace is followed by semicolon, though, unlike a class definition, is because the entire expression is going to be used as a Java statement. The beginning part, repeated as you can see below, may seem strange. New number carrier. That looks a little familiar. The new part is very sensible because we're creating a new instance of it. But what's the point of number carrier? This looks like an invocation of a constructor for number carrier. However, if you recall, number carrier is not a class. It's an interface, and therefore, because it's an interface, there are no constructors. Therefore, the meaning of new number carrier is simply to implement the number carrier interface. The anonymous class that we use here implements the number carrier interface and is defined, therefore, between those two braces. So, lastly, let's kind of start closing out on some thoughts here. Why use inner classes? Well, most simple situations don't require us to use inner classes. However, there might be situations in which inner classes are a good solution. So, for example, let's say we want a class with 2 base classes. If you recall, this is not allowed in Java. However, if you have an outer class derived from one base class with an inner class derived from the other base class, because the inner and outer classes have access to each other's instance variables and methods, this can often serve as if it was a base class with 2 base classes. If you only need one object class and the class definition is very short, many programs will actually like to use things like an anonymous class in order to help them with their code. And one more time, let's go over to Eclipse and take a look at our code here. So here is that number carrier interface. You can see, again, it's a very simple interface. All we have here is 2 methods, a set number and a get number. And if I look over here at the actual main program, you can see here in our main, which is this line of code right here. In fact, you can see we do not have anything else other than this other method right here called show number, which of course is not a method that belongs here because those methods are actually constructed elsewhere. Because we can see right in here, we have a inner class that we're creating effectively. So let's look at this a little bit. So we got number and object equals new number carrier. And this, of course, is treating this as a interface object. So this is our inner class is the way it's trying to do this. But again, remember, number carrier is an interface, not a class type. And so then, of course, it creates a private int number, a public void set number, a public int get number. And down here we have another number carrier object. Again, it's treating it as though it's a class type. But again, number carrier is not a class type. It is an interface type. And so you can see how that one is actually implemented here. Now this, of course, effectively allows us to treat these two as 2 inner classes. However, down here is the actual code that then gets used. So we have an object.setNumber, another object.setNumber, show number, and then end the program. Show number, remember, is down here as this other method, which if you remember, is going to, in this case, simply just print out whatever number is passed in. You'll see it is of type number carrier. Again, remember, it's using an anonymous class object here because number carrier is an interface that exists, not a class type. So let's go ahead and just give this a quick spin and see what we get produced. And you can see we get the value of 42 and then the value of 84. So if we look down here, we have an object.setNumber, which means that it is setting it to 42. And then we have another object.setNumber. We're passing in 42. So these, of course, are using, again, that set number value that is coming from here, which we have defined up here. And one of the things you'll note is that this one's just number equals value, but this one's number equals 2 times the value. So that's how come we get 42 and 84. And then, of course, we have the end of program because show numbers will print those out for us. And this is simply just that termination statement. But that's going to kind of wrap up our dealings with inner classes. And that's going to conclude also our lessons on everything that we need for this course section. So hopefully you've enjoyed and gotten a lot of material and good knowledge out of what we've done here within this second level programming. And hopefully you look forward to seeing what we will do with the next tier.